Alright guys, we're going to look at the last of the solving techniques for a quadratic equation called the quadratic function. You've seen this before. It's intimidating, it's scary. It's got lots of symbols and square roots and pluses and minuses and all kinds of things, but we're going to make it simple. This thing is a very powerful formula. It solves all quadratic equations, no matter their look. It isn't always the best method to choose, because there are other methods that may be faster or simpler, but what the power of this guy is, it works every time. So let's take a look at how it works, and hopefully you'll understand it. Here's an equation, and I guess I want you to understand something before we get going too fast. This actual guy here, I would actually solve using factoring, which I will. Well, maybe let's do it first. Let's factor this out. It would be x, let's see, minus 5, x plus 1. And so our two solutions would be 5 and negative 1. Now let me do this using the formula to prove that we could obtain the same goal, but in truth, I would not use the formula on this one. I would use factoring. But this is a good one to practice with. So our a equals 1. Our b equals negative 5, and our c equals, negative 4, and then negative 5. When we put this into the formula, we get the negative of negative 4 plus or minus b squared, which is negative 4 squared, minus 4. A is a 1, and c is negative 5, all over 2 times a, which is 1. Let's bring that over here and simplify it a little bit. We get 4 plus or minus 16, and then we get plus 20. Where did the plus 20 come from? Because back here, if I'll highlight it quickly. Here, this multiplies. The negative 4 and the negative 5 make positive 20. So this keeps simplifying. 4 plus or minus the square root of 36 over 2. That's 4 plus or minus 6 over 2. And then you have two possible answers. You have 4 plus 6 over 2. And that's, of course, that's 5, because you get 10 divided by 2. And the other one would be 4 minus 6 over 2. And that gives you a negative 2 over a 2, which gives you an answer, and I'm running out of space, but of negative 1. So, as we expected, there's our 5, and it matches our 5 here. There's our negative 1, and it matches our negative 1 here. Now you can see my argument that there is sometimes times that it's better for me, I like this versus all this other work. But the point is that this formula, once you get used to it, it produces lots of answers for you. Let's do another one. Now here's an example where I cannot find two numbers that multiply to 14 and add to 8. So this is a good example when I do need this guy. I could complete the square there, but for sake of space and other things, I'm going to do it using the formula. So it's the negative of b plus or minus b squared minus 4 times a times c, all over 2 times a. This is negative 8 plus or minus 64 subtract 56 all over 2. This gives me negative 8 plus or minus, so let's see, 8 would be that number, all over 2. Then we bring that up here, I get negative 8 plus or minus, and this kind of does a quick little simplifying, all over 2, negative 8 plus or minus 2 root 2 over 2. And then finally 2 divides into negative 8, and 2 divides into 2 root 2, leaving us this answer. Here is our answer. It's 4 plus the square root of 2, negative 4 plus the square root of 2, and negative 4 minus the square root of 2. You can see, again, the power of this kind of formula. Let's do one more. Alright, here's another one to try. Again, I would look factoring first, and I notice that I could factor this. Two numbers that multiply to 16 but add to 8, of course, are x plus 4 and x plus 4. And so our two solutions, or our solution would be a negative 4, right? Because there would be 1 there. So let's see if we can match that in terms of our work. A equals 1, B equals 8, C equals 16. The negative of b plus or minus b squared minus 4ac all over 2a. I get negative 8 plus or minus 64, subtract 64 all over 2. This comes up here, I get negative 8 plus or minus the square root of 0 over 2. This is 0. And because it's 0, there's nothing to add or subtract, so we just get negative 8 over 2, which is negative 4. That brings us back to our original finding, was that the solutions to this problem were just a single solution of negative 4. What does that mean? Well, it means that our parabola is sitting right there, and we solved it for its one point, the vertex. Hopefully this helps you do some solving with the quadratic formula.